Hey guys. Okay, so we have currently at this particular moment, we are balancing equations, and now we are going to take those balanced equations and we are actually going to look at something fun known as chemical reactions. But in order to do that, we need to know the different types of chemical reactions because you may have noticed there's a certain pattern on how you see the products and the reactants. And so you'll see the same kind of atoms in each of the products and the reactants, but they're completely different after some sort of reaction has yielded. And so we're going to go ahead and identify those types of reactions and hopefully be able to identify this in the lab after you get a product. After this video, you should be able to define and give general equations for combination, decomposition, single replacement, and double replacement reactions. You should be able to classify different types of reactions. And finally, you should be able to predict products of reactions given only the reactants. So hopefully you'll start to see these patterns. That very last point there, I'm not expecting you to be able to do anytime soon. So don't worry, we will get up to that point. Okay, so before we can progress on, there are some basic things I want you to know. The 5 basic types of chemical reactions are combination, decomposition, single replacement, double replacement, and combustion. And just looking at those words, you can probably tell what's going to happen. So for example, combination, things are probably going to combine together to make one. Decomposition, the breakdown. Single replacement, we're replacing one with another. Double replacement, we're replacing two with another. And combustion, boom. So again, these are the categories that we can generally replace each kind of reaction into. Some reactions actually can fit into more than one category. So don't get frustrated if you're like, I can see this in both. So let's go ahead and start by talking about combination reactions. Remember, I will be adding notes in class. You need to leave room, especially in between each type of reaction. The reason why I put them so close together is because I wanted to limit the number of slides I have. But I am going to give an example and I'm going to talk about all of these in a little bit more detail in class. So a combination reaction is a reaction in which 2 or more substances combine to form a single new substance. Combination reactions can also be called synthesis reactions. So basically it's like A plus B yields AB. That's a combination reaction. So basically we have 2 elements and they combine together to form a compound. So and again, we'll see these and I'm going to give you some examples in class. So please don't freak out if you're like, I don't understand this. I think that of all of the types of reactions, this one's the easiest to identify because you go from 2 separate things to one whole thing, depending on what is actually being combined. So what I mean by this is like, let's say I combine non-metal with a non-metal, I can create different molecular compounds. So for example, if I were to combine sulfur and oxygen, there are different compounds that can become available. Another great example of combinations is transition metals with non-metals. Those can also form different products just because of the fact that transition metals do not have a set number of valence electrons. Another way that you can see combination reactions is by combining an already combined compound. So like, let's say CO, carbon monoxide, reacting with oxygen gas, and that helps to create carbon dioxide, which is also a gas. So there's other ways that you can see this combination, not just A plus B. We could also see AB plus C gives you ABC, or whatever the case may be. So I wanted to make sure that you're understanding that. The next reaction we're going to talk about is what's known as decomposition reactions. Based off that name, hopefully you'll understand that there's a breakdown somewhere. So a decomposition reaction is a reaction in which a compound breaks down into 2 or more simpler substances. So the general formula for that one would be AB yields A plus B. Again, these are very generalized. You'll see a few exceptions to these rules, and you'll also see that some things don't fit perfectly in a box, and that's okay. Most decomposition reactions require input of energy in the form of light, heat, or electricity. It's also really important with this type of reaction that you know how many elements are present in the compound. So for example, if I have mercury combined with oxygen, and they yields mercury and oxygen gas, there are only 2 elements in that compound, that's known as a binary compound. And this is the simplest kind of decomposition reaction, when a binary compound decomposes into its elements. But you can also have like a huge compound that has more than 2 elements in it, and then that breaks down into simpler compounds, but they're not as I can't even think right now. Sorry. They're not as complex as, or excuse me, not as simple as my previous example. And again, I will write this in class and I will show you this in class. So please don't freak out if you're like, I don't know what she's saying. Because we all know that's generally the case. Because I suck at explaining things on these videos sometimes. The next type of reaction I want to talk about is what's known as a single replacement reaction. And again, you can probably infer what these things are doing just based off the names. But a single replacement reaction is a reaction in which one element replaces a similar element in a compound. So that basic breakdown of that would look like this. A plus BC yields AC plus B. So a great way to show that, again, it's just a single replacement. So we're replacing one thing. Instead of having the B bonded to the C in the products, we now have AC instead of BC. In this general reaction, element A is a metal, and it replaces element B, like I just said. And element B will also be a metal. So A will always replace another metal in the compound. When the element that is doing the replacement is a nonmetal, it must replace another nonmetal in a compound. And so basically, metals replace metals, nonmetals replace nonmetals. When we're dealing with hydrogen in particular, in a hydrogen replacement reaction, the hydrogen in the acid is replaced by an active metal. And I'm going to give you an example of this, so please don't freak out if you're like, what? And so the same can be said for when we're talking about a halogen, or not the same thing, but there's a little bit of a rule when we're talking about halogen replacement. So when it comes to halogens, the reactivity is really the most important part. Remember, as you go down a group, the reactivity becomes less. So fluorine is the most reactive halogen, while iodine is the least. And so when we're talking about replacing these, it is the most reactive element that will do the replacing. And again, I am going to show you an example of this, so don't freak out. This leads into the conversation on the activity series. So single replacement reactions only occur when the element that is doing the replacing is more reactive than the element that is being replaced. Therefore, it is useful to have a list of elements in order of their relative reactivities. You have a periodic table, and on there you have trends. One of those trends happens to be reactivity. I suggest you get that out and make sure you know that. We are going to go over that in class as well, so don't worry. So since metals replace other nonmetals while nonmetals replace other nonmetals, they each have a separate activity series. And I already have it on here in activity series. There's a list of elements in decreasing order of their reactivity. I'm going to show you what this looks like in class, that nice list. In your reading, there's a nice little table on there. It does a nice job at really just breaking it all down. But I will show you this, and you'll probably write this down in your notebook as well. The next type of reaction is a double replacement reaction. So this is a reaction in which the positive and negative ions of 2 ionic compounds exchange places to form 2 new compounds. So for this general look, it's AB. You can probably guess what I'm going to put. Plus CD yields AD plus CB. Very general. So in this reaction, A and C are positively charged cations, while B and D are negatively charged anions. Double replacement reactions generally occur between substances in aqueous solutions. So there are some tricks into figuring these things out if you absolutely don't know. Generally, when you see the aqueous everywhere, probably double solution. I said double solution, I meant double replacement. In these types of reactions, you're generally going to see a formation of either a precipitate, a gas, or a molecular compound. And we'll talk about all those in which case scenarios we see those again in class. Probably the best the best reaction that most people enjoy is what's known as the combustion reaction, a reaction in which a substance reactants react with oxygen gas, releasing energy in the form of light and heat. So a big boom, if you will. Generally, you're going to see this when carbon and hydrogen are present in some format. The products of the combustion generally form carbon dioxide and water. So, for example, propane is a gaseous hydrocarbon that is commonly used as the fuel source in gas grills. And that's pretty much it. That is your types of reactions. We will practice on how to identify these. I know you watch these videos and you're like, I don't know why she expects me to know all this right away. I don't, but I do want you to be exposed to it before you come to class so you're not going crazy thinking, oh, I've never seen this in one day in my life when I've kind of already talked about it. So if you have any questions, please make sure to ask me on Edpuzzle.